We talk about the physical nature of perception and voluntary movement. This is a ongoing work of which was presented at the meeting of Neuroscience Society for Neuroscience in Washington D.C. late last year. So this is the first slide, which is from that poster. Basically, I proposed that there are P objects that are created as a result of information processing. These contain bits of information, bits of classical information, which are erased as the entropy or randomness in the brain's activity pattern are reduced as a result of interaction of the brain with the environment. And this reduction in the randomness or entropy is responsible for the knowledge that underlies perception and voluntary motor control. Uh, and uh, in the further in research, I'm trying to understand the nature of the object, how it is created. So for this, I'm going to be using quantum mechanical physics because those bits of information are very small packets of energy and they're likely to be exhibiting quantum mechanical behavior. This is the next slide, which shows quantum particles such as atoms, electrons, protons. Shown here is the electron gun that fires a stream of electrons passing through slits. Those once they pass through these two slits, one and two, they create a pattern that seems to be formed by interference of the waves, which suggests that electrons uh, propagate like waves, and once they are detected as particles, which forms patterns on the detector screen, uh, and those patterns resemble interference pattern. So there are light areas which are rich in electrons, dark areas where there are hardly or no electrons. This can be explained if light or rather electrons passing through the slits propagate like waves. Two waves from slit 1 and slit 2 will interfere, forming the pattern which is shown here. And this you can see right here. You can see the pattern of formed from interference of photons. So when the position of the photons are measured on the screen, it creates dark and light alternating bands that result from interference of wave-like propagation of photons in this case. In short, it means that quantum particles can be both behave like both the particle or wave. Now we come to next uh, type of important type of quantum behavior that is relevant to my work. It is called quantum entanglement. So if two quantum particles are created together, then they get entangled, which means that they can communicate with each other even if they are hundreds of light years away, or if and the communication is instantaneous, it is as if there is no space between them. Almost seems that way. Mathematics helps us to understand their behavior, but we don't fully understand quantum mechanics. We just accept accept them as being true. So there is a communication which violates locality. We will talk about that in a bit. So some rules of classical physics are violated, such as entanglement is maintained even if the quantum particles are separated by large distances, like millions of light years away. They also exhibit non-causality, which means that the difference between cause and effect is lost. Present can affect past, past can affect present. Um, and now that we have seen, learned something about the quantum physics, let us see if we know about some examples of quantum physics in biology. These are some examples. Uh, Birds can navigate large distances over the planet just with the help of the Earth's magnetic field that is believed to be due to quantum mechanical effect. Enzyme catalysis is due to an effect called uh, quantum tunneling. So basically, electrons can cross the barriers um, that are normally not easy to cross using classical computation, but quantum mechanical calculations allow them to cross the barrier, which allows the electrons to build chemical bonds, resulting in catalysis. Photosynthesis is a well-known example of quantum mechanical physics in biology, and here the electrons can jump into superposed excited states, and those are helpful in efficient photosynthesis. And then it is believed that microtubules play a role in human consciousness. It is still under study, not well understood at this stage. Then, before I talk about my work, I would like to explain what is a qubit. To understand qubit, we have to understand superposed states. So, what are superposed states? So, superposed states are alternate basis states, uh, which can be present in the same particle, such as spin. So a particle can have both spin directions up and down. And only when we measure it, we learn about the direction. But before the measurement, it can be in both at the same time. And so that is also called qubit. Qubit is um, similar to classical bit carrying information, but classical bit is either head or tail, but a qubit is both head and tail at the same time. So both states are described by notations called cat. This is one cat state, the other is other cat state, cat 1 or cat 0. As we see in the next slide, so this is cat 0 state, this is cat 1 state. There are specific probability associated. It's just superposed states. So these are superposed states. These both states are present at the same time, and there's a different probability for each state, depending on which we can find the particle, which is the likelihood of finding a particle in a particular stage. So once we measure the state, it can be either up or down. So once we measure the state and we find either up or down, then all the information about the probability associated with each state is lost. So a single measurement is not going to help us find. However, nature has made it possible to keep the quantum information intact, and we don't understand why it is, but we accept it as a fact. So this is a superposed state of cat 0 and cat 1, each with a different probability. This is actually uh, probability amplitude. It's a complex number. Probability will be a square of alpha square and beta square. Now that, so this is a qubit, having both states at the same time, each state associated with a probability, and that probability is a amplitude of a wave function, and that keeps changing, um, just like a wave, the amplitude will change, and we will apply this knowledge to understand how qubits play a role in perception, and voluntary motor control. So in order to understand that, we go to this slide, which is a simple diagram of a multipolar neuron in a temporoparietal occipital area, which is a area that is associated with uh, consciousness. Here we have this neuron which receives input from visual and neuron from occipital area, and then you have auditory neuron from temporal area. This may be in parieto-temporal uh, occipital area anywhere. All of these contain neurons that process all sensory modalities. So basically, uh, action potential is the basis of information processing. So when we interact with the environment, our receptors are stimulated by objects in the environment, which are called stimuli, and we perform movements to manipulate the objects in the environment, and all those produce activities that are communicated within the brain with the help of action potential or spike. So that is the very basis of bringing the external information into the brain for any processing to happen. So to understand how action potential is generated, let me quickly review that. Action potential is generated when uh, voltage gated sodium channel opens, and that triggers action potential. So voltage gated sodium channel plays a key role. It's like a on and off switch. And we will learn that this on and off switch can be controlled by a qubit, which is in a amino acid called arginine. So this qubit will control on and off of on and off states of sodium channel uh, by uh, collapsing the superposed quantum state of electrons in arginine side chain. So this will become clear as we progress through the presentation. So basically, in summary, action potential are controlled by voltage. So what controls the voltage? The voltage is the result of the sensory input. If the sensory input is more and faster, voltage will develop faster and there will be greater rate of voltage increase. And if the similarly for motor movements, if movements are uh, vigorous, then will be more uh, inputs resulting from motor neurons that are synapsing on this multimodal audio-visual or multimodal neuron. So, going back to why arginine is important for controlling the turning on and off of the sodium channel, acting like a switch. So here we have the reason to believe that. So there are arginine residues in the S4 module of the sodium channel, and if we alter those arginine residue or replace them, then it will reduce the sensitivity of sodium channel to voltage. So it won't be able to act like it won't be able to turn on and off. So there must be something about arginine that makes it capable of doing this. And we will see the structure of arginine here. So arginine has a side chain. It has delocalized electron. A delocalized electron can, uh, the position of the delocalized electron can be any of these three nitrogen atoms, and that will also move the positive charge, and that will change the way in which this side chain will form hydrogen bonds with other parts of the sodium channel, and that could be potentially responsible for controlling the voltage sensitivity of sodium channel. So, assuming that delocalized electrons are in superposed states, multiple superposed states, and when its position is determined in any of these three three bonds, then that would result in the uh, opening or closing of sodium channel by making and breaking hydrogen bonds. And these superposed states will be associated with the probability amplitude that would be in turn associated with the voltage. Thus, the voltage might control the probability. If there is more negative voltage, it may increase alpha or beta. If there is more positive voltage, it may increase beta or alpha. Both are possible. I don't know that yet. So, but by controlling these probability amplitude, the change in the voltage will in turn affect the probability of these superposed state, thus controlling the uh, turning on and off of the sodium channel. So these are acting like qubits having superposed state, and they are also present in a part of the molecule that is relatively seems to be unaffected, seems to be inside the molecule, and thus it is less likely to be affected by uh, the motion of other the heat energy or other types of molecular movements can affect, and they can decohere or they can cause the collapse of the superposed state. So even if these superposed states last for a very short time, that is enough to produce to create a qubit. that can be entangled, even if the qubits are created at different time points, not at the same time. Uh, they may still be entangled because of non-causality. So uh, they don't have to be in the same exactly at the same time. And so the entangled qubits, or what I call them P states, are basically going to keep the information about the external interaction uh, in the probability amplitude of different superposed states in different qubits, which are entangled, and that may be that is a quote and unquote hidden information, which is preserved and which may be responsible for perception and voluntary movements. So this shows how different. This is A for auditory neuron, V for visual neuron, AV is the multimodal neuron. So these are qubits that are entangled. These are different superposed states of qubit that are responsible for how the electrons are positioned to make and break hydrogen bonds. And so these are affected by the probability amplitude, which in turn are controlled by the voltage. So at different time points, different qubits are created, and uh, they are quickly they decohere, or they become stabilized in one of two positions corresponding to open and closed sodium channel, uh, which is the measurement of which quote and unquote measurement of electron position from superposed state, resulting in conformational changes in the sodium channel. So those qubits will appear and disappear quickly, and that regular appearance and disappearance of qubits will be, or the p states will be responsible for the dynamic nature of the perception and voluntary movement. So this is a slide about probability and probability amplitude. This is probability amplitude is phi. Phi square is probability. So, and this is just a description of the wave-like nature of the qubits, alias p states. And I also propose that there could be an interference pattern by entangled particles, because entangled particles, the probability amplitudes may cancel or augment each other depending upon the phase. Um, and that would be also contributing the perception. And this is possible because the interference of uh, P states wave functions is possible because P states or qubits which are entangled, they communicate instantaneously, which implies that there is no space, and and that is why interference is possible. So that ends this talk. If you have any questions, please ask.